Welcome to BKW Physics. I'm Mr. McConnelly, and we're going to do left-hand rules. Now, yesterday we did the first left-hand rule, and this is just a practice problem that we can look at. And what I'm asking in this problem is what would be the direction of the magnetism at point A on this diagram? So, first left-hand rule, what do? Thumb points electron flow. Alright, so let's say the electron flow is this way, out of the battery, out of the short end of the battery, going this way. So our thumb is following this wire. Round and round. Now we get up to this point up here, let's kind of figure out what's happening to the magnetism, because I'm interested here. So if my thumb's following, what do I do with my fingers? They bend in the natural direction around the wire that you're speaking of. So in this case, if you can imagine, if I make this a little bit more 3D, if this is the wire right here, and my thumb is following the wire, my fingers are going to wrap naturally around this way. So in other words, the magnetism is around the backside, like that. Is that clear the way I drew that? How about on the other side? As I continue to follow along the electron flow, now my thumb is pointing down because I followed it. And now I'm going to wrap my fingers around. My fingers are going to tuck around back here, like this. So generally speaking, what do you notice about point A? I'm exaggerating by drawing more lines, but can you see how the flow... kind of the way I drew it on the board is down, but in reality, if this piece of paper were flat this way, it would actually be out towards you, right? Okay? Yeah. It's really hard to draw three-dimensionally, but you see what I'm saying? Because this is kind of my fingertips are coming towards you, fingertips are coming towards you, so that magnetism is coming towards you. And one thing I failed to mention yesterday is the letters for magnetism. You know how everything has a variable? The letter for magnetism is a B, capital B. Just so if you see that, you know what they're talking about. Now, we're going to move to the second left-hand rule. And the second left-hand rule specifically applies to situations where you have a coil. Coil could be drawn something like this. For instance, if I take this iron tube here, piece of iron tubing, and then let's wrap a wire around it. Now I'm going to do this in a very specific way, so watch the way I draw this. Don't miss this part. As the wire comes up here, I'm going to go over the top and then behind the back. Then I come out over the top and behind the back. See the way I'm doing that? It makes a difference. I'm not just being silly. So basically, I have a current carrying wire now, which is like the first thing. But now the current carrying wire has been wrapped around a ferromagnetic piece of iron. Okay? Here's what we do. This time, your fingertips, we should say, follow the electron flow. And your thumb, this time, points towards the north. Points towards the north. So get that down quickly. Alright, so let's play it out. Here's how it works. So my fingers this time, last time it was my thumb following the electrons. Now we've changed rules. We're on the second left-hand rule. I know it's a little confusing, but your fingers got to follow the electron flow. So let's get the electrons flowing like this. There they are. My fingers are following. Now what happens when they go up and over this way? Well, just as the wire shows, have your fingers follow. So your fingers go whoop. When your hand gets in this position, whether it be this way or this way or this way, when your fingers are bent, in other words, you have followed it around the coil, that's where you stop, and you look which way your thumb's pointing. That's the north. So what this is going to produce is when you coil wire around a piece of iron, like taking a wire and wrapping it around a nail, and then you hook it to a battery, it produces a magnet. Okay, so this is an electromagnet. And in this case, this is the north, so obviously this is the south. So the magnetism, remember our magnetic field lines point from north to south. Is this ringing a bell? And what happens to the magnetism when it travels to the south? It returns down the center. And I failed to mention that yesterday. I mentioned to everyone in my class, but on video I forgot to mention that magnetism loops are complete closed loops. So if you start here, they go through the air, and then they travel back through the iron core. So you have a complete loop here. Where's the magnetism the strongest on this? Where's the flux density the strongest? Closest to the poles, and if you're looking at magnetic field lines, it's where the lines are closest together. So you can see those are close, that's going to be strong. These are far, that's going to be weak. Sound good? The last left-hand rule, called the third left-hand rule, is a situation where you have an external magnetism, external magnetic field, and you have a wire that's going through that magnetic field. Maybe something like this. You draw yourself a horseshoe magnet. And I'm going to try to draw this to a certain extent a little bit 3D. I have a reason for that. So we'll just make the picture a little bit easier to understand. See all I did? Kind of gave it that 3D effect. Now I'm going to run a wire right between the north and the south, loop it back around. I guess it doesn't matter, we can put the battery in either way. Alright, so what happens here? Well, first of all, on this rule, our thumb is again the electron flow direction. So we're back just like the first left-hand rule, our thumb is now the electron flow. Our fingers, though, have a different role, I guess. They point in the direction of the magnetic field. In other words, north to south. You know, because remember, magnetic field lines go north to south, so your finger's going to point towards the South Pole, or north to south. And this time, you got to pay attention to your palm. And your palm is going to show the direction of the force on the wire. So, this seems a little complex, but it's not bad when you go to actually do it. Here we go. First of all, which direction is the electron flow? Well, say that it's coming out of the battery this way. So by the time we get over here, the electron flow is going that way. Good? Which way is your thumb pointing then? Boop. You know, whichever, you can turn your hand. At this point, you don't really know which way to turn your hand, so your thumb is just pointing that way. But the second thing says your fingers need to point in the direction of the magnetic field, or north to south. Your fingertips need to point towards the south. So, when I'm at this position here, with my thumb going this way, my fingers have to point towards the south. And you gotta kind of visualize this a little bit 3D, because this wire is kind of like going almost into the board, you know what I mean? So my thumb's kind of going into the board, kind of at an angle like that. My fingers are north to south. Which direction is my palm pointing? Oh. And if you can see that, you have just realized the direction of the force. And some of you are thinking, well, what force? What are we talking about force? I didn't know what force was happening. When you run a wire between a magnet, between a north and a south, and then you run current through the wire, remember, the wire produces its own magnetism. So visualize this. I don't want to, don't draw this on your own picture, because it'll cob up your picture. But envision this. since this has electrons flowing this way, it's also going to have magnetism that is wrapping around the wire like this. Can you envision that from the first left-hand roll? Then you're exposing this magnetism, the yellow one, to this magnetism of the external magnet, and the two magnetisms start fighting or working together or fighting against one another, depending on the direction, right? So what ends up happening is that this wire will literally get pushed up. If you take a wire and put it between a strong magnet and you run a lot of electricity through the wire, you will see the wire go and get bent or get moved upward because the two magnetisms are fighting each other. In this case, the force would be up, it would get pushed up. So these are the three left-hand rules of magnetism for today. Physics.